Greetings, this is M squared, and we're going to talk about properties of radicals. We're really not going to do any examples in this, but it's really important that you understand the properties of radicals so that when you're simplifying, whether it be adding, subtracting, multiplying, or dividing, or using the 3 rules of simplification, that you know the properties. So anytime you have two things multiplied next to each other, and you might not notice, it might just say 30, but that's 3 times 10. So it doesn't have to actually be two different things being multiplied. It can be something that needs to be factored as well. You can always split that up into two things with the factors in each radical. So some examples would be the square root of, and it goes both ways. It can go from the right side to the left side or left side to the right side. And I showed both examples. If you have radical 3 times radical 27, you can multiply them together and get radical 81, and then it's much easier to take the square root of 81. Likewise, if you have the 5th root of 64, you can split that up into the 5th root of 32 times the 5th root of 2, because the 5th root of 32 is actually 2. So you can split it up into things that are perfect, or that can come out of the radical to be an integer, and things that don't. And it works similarly when you have when you're dividing or when you have a fraction. You can make two radicals that are being divided into one fraction as long as they have the same index. Or you can split up a fraction into two radicals. Remember, one of your rules for simplifying radicals is that you can't have fractions underneath a radical sign. So sometimes we go this way, and then we say, oh, well, we can't have radicals in the denominator, so then we have to rationalize the denominator. But this little property is important to remember. So an example I give is two radicals being divided, and I can put them under one radical and then cancel. So 2 goes into 16 8 times, and x to the 7th, and x divided by x. Remember, we subtract exponents, so 7 minus 1 would be 6. And then I can take the cubed root. I could split it up into this if I wanted to. The cubed root of x to the 6th is x, and the cubed root of 8 is 2. So you can kind of simplify using that property. Some things to keep in mind: when you're adding radicals, you can only add like radicals. You can only add a radical x to a radical x, or a radical 4, well, not 4 because that changed to a radical 3 to a radical 3. And all you do is add the outsides, the coefficients. Similar to when you would have just said 4x plus 7x would be 12x. Well, 4 radical x's plus 7 radical x's is 12 radical x's. When you're multiplying, it's outside times outside, inside times inside. What's outside stays on the outside, and what's inside stays on the inside, but you can use the other rule of simplifying radicals. If there was something perfect in there, like a perfect square or perfect cubed, if you were doing cubed roots, etc., you could take that out. But outside times outside stays outside, inside times inside stays inside, unless you can simplify it. And then when you're dividing, you have to remember to rationalize the denominator. I call them rats. No rats in the basement, or no radicals in the denominator. So if you were given this, the problem with this isn't that it has perfect things or that there's a fraction inside a radical. It's just that you have a radical in the denominator. So to get rid of that, it depends on what our index is and how many factors we need. We have one factor of 5, so we would need one more to get the 2 that we need. So once we figure out what we have to multiply the denominator by, then we have to multiply the numerator by that same thing. So we multiply the top and bottom of this fraction by radical 5 over radical 5, and then we get a radical 10, because inside times inside is 10, and it stays inside. And then inside times inside, that'd be square root of 25, but the square root of 25 is 5, so it's 4 times 5, which is 20. You cannot reduce these. Be really careful. Remember, just like when you're multiplying outside times outside, inside times inside, you cannot divide something that's inside a radical with something that's outside a radical. So be really careful with that. So hopefully that helps as you're simplifying radicals, and we will do that in the next few lessons. M squared, signing out.